least that will give you some thought. Chalo. So a little bit about vectors so that we understand. So I told you about vector translation. There is something called resolution of a vector or resolving a vector. This is an interesting and important concept that you should understand, though your book doesn't tell about it. Now, suppose there is a vector, and the easiest way to understand a vector is a force. This is a vector and this represents a force. Okay, this is F as a vector, F vector, and it represents a force. This vector can be either thought as a vector in this direction, or we can resolve every vector. Every vector can be resolved into two components. One is called the vertical component of a vector, and the other is called the horizontal component. Horizontal component and vertical component. Sir, what are those two things? So let us understand them. Okay, a horizontal component of a vector is along the horizontal direction, all right, and a vertical component of the vector is along the vertical direction. What is the meaning of this? That is more important. What is the meaning of this? Such that they should be able to complete a rectangle. Okay, so let me first make the rectangle such that okay, 1 minute, children. Right. So this F vector has been resolved into two components. One is the horizontal component and one is the vertical component. Horizontal means it is along the X direction. Vertical is along the Y direction. We can call it as FH, FV or FX and FY. अब meaning समझो इसका क्या है. When you resolve a vector into two components, then from your mind you abolish this vector. Eliminate this. What do I mean to say? Suppose there was a ball out here. Suppose there's a ball out here, right? Or let's say, don't get interested in only drawing. Understand this. That's why you all are scoring less. You all are drawing it. If I draw a coconut also, you will draw. First understand, what is this drawing all about? Then your concept will become clear. Suppose there is a ball out here and you are pulling the ball with this F force. Where do you expect the ball to go? The ball will be going in this direction. Forget the F force. Now try to pull the ball simultaneously with Fy and Fx. Then also the ball will go in this direction only. Yeah. Take a string and try to pull it by this much and this much. Where will the ball go? It will go in this. You don't believe it? Again, bad example. लेकिन सुनो, आप जब टायर्ड होके आके अपना डेनिम जीन्स खोलते हो, बटन खोल के जिप कैसे खोल सकते हो? खींच देने से जिप खुल जाता है ना. You're pulling on one this side and one this side. The zip runs down exactly straight. Look at about a parachuter. This is a parachuter. How is the parachuter pulling? This direction, this direction. But the parachute is coming in which direction? This. This is the resultant force of these two forces. As simple as that. That's why every morning when these kids, our typical Pebble City kids, are taken to the bus stop, both parents will hold their hands and take it. The bacha goes like a vector addition. Mama pulling this side, dad pulling this side. बच्चा टिक 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 सामने जा रहा है. Imagine ना, आप सोचो ना, थोड़ा एक मिनट सोचो तो. Think of a ball and you pull the ball exactly in two directions. One along this direction, one along this direction. The ball will flow along the diagonal. Has to move. So here comes vector addition, where we say that F as a vector is the vector addition of Fx and Fy. Vector addition. This is not general addition. Vector addition. Have you understood? Therefore, in vectors we say, suppose if this Fy was something like 3 Newton and this was 4 Newton, then F will be 5 Newton. If this is 3 Newton and this is 4 Newton, vector addition doesn't make it 7. Hypotenuse hai ye. So this will be 5 Newton. It will be root over fx square plus fy square plus f will be actually, if the magnitude will be root over fx square plus fy square plus 2 fx fy cos theta. And cos theta is, this is the angle theta. What is this angle? 90 degree. Cos 90 is 0. Therefore, it becomes fx square plus fy square. Cos 90's value is 0. समझ में आ रहा है? Any vector can be resolved into two components. Many a times it is important for us to understand that actually which component is playing the role. Which component, like say suppose in grade 11 you will get a problem. A fisherman wants to keep his boat fastened to a particular place ताकि उसे पानी बहाना लेके जाए. So what are the forces? These are actually the, if you look from here, there's a tension force on this side, there's a tension force on this side. This tension force can be again split into, this is say tension T1, so this is T1, if it is T1 in the y direction, and this will be another force which will be T1 in the x direction. Similarly, there is a tension force T2, this will be T2 in the y direction, and this will be again in this direction, T2x. Now, if the boat does not move, so the rule is what? This force and this force should cancel each other. That's how you calculate. And these two forces also have to cancel it. Then only the boat is not going to move. Or the boat will, if there is a resultant force here, the boat will come on this side. समझ में आ रहा है? And if the boat is not moving on this, then there will be some water drag force on this side. Water is pushing the boat away. Fisherman has tied two strings. So let's say this is the water force. And then the question in physics they'll ask, determine what is the tension on this rope. So under equilibrium condition, boat is not moving. X direction forces balance each other, Y direction forces balance each other. That is the concept you have to put. So at that time, this tension force has to be broken down into its two components. This thing you always remember. Now let us see what are each of the components. Okay, how to find out these components. Then after that we can start our chapter. Let's say I have a vector, and since your chapter is all with force, I say that this is F. So what is the component along the x-axis? The component along the x-axis is called Fx. Understood? Now between F and Fx, say suppose I have an angle theta, right? And I now need to find out, I know the value of this. This is say 5 Newton. I don't need to find the value of this. How do I find out? Whenever you're working on x side, we take the cos. What is cos of this? Adjacent side by hypotenuse. Fx by f. So my fx becomes equal to f cos theta. That means this component is always f cos theta. And similarly, if somebody would have told you, find the value of what do you call vertical component, fy. Okay, find the value of vertical component. So this is say fy, and you find the component of this. So I can't calculate this directly, but I'll complete this triangle. And in this triangle, this is also the value of fy graphically. Right? Now you take sine. Sine theta is opposite side fy by adjacent side f. So my fy is always f sine theta. So whenever you see a force or any vector, the vector can be momentum, the vector can be displacement, the vector can be force, it can be resolved into two components. Horizontal component is always f cos theta, vertical component is always f sine theta, and theta is the angle between the vector and the horizontal. The vector and the horizontal. Again, given a horizontal place and given a vector which is making an angle, say this is a vector A A makes an angle theta, then the component of A along x-axis AX is always A cos theta, and the component along this is always A sin theta. ठीक है? चलो बोलिए। हाँ बोट वाला एग्जाम्पल, हाँ चलिए बोट वाला एग्जाम्पल फिर से देखते हैं, ठीक है? आओ चलिए, लेट्स सी द बोट वाला एग्जाम्पल. So this is water and there is a current in the water which is flowing in this direction, right? A fisherman has kept his boat in this manner. He's done with fishing, ठीक है ना? And he is now tucked his boat into some bamboo. ऐसा कोई bamboo है, इसमें अपने बोट को दो तरफ से बांध के रखा है, right? And the boat is stationary, right? So you'll not understand. There is a one sort of force is also known as tension force. Tension. To understand tension, we always say wherever you want to calculate tension, sit there and open an umbrella. So you're sitting here, you open the umbrella will open in this direction. So this is tension in this rope. If the tension is broken, boat फट करके चला जाएगा, ठीक है ना? So there's a tension T1 on this side. Similarly, there is a tension T2 on this side, right? At this time, they say boat is not moving. So you try to say, for example, boat is not moving, and they say calculate. These are pure classical mechanics problem. Calculate what is the tension T1 on the boat, right? And the problem says T1 makes an angle alpha, T2 makes an angle beta. So beta करके रखें. At this moment, what we draw something called a free body diagram. ठीक है? आइए free body diagram देखते हैं. Free body means all this water and all gone. We will now bring this into pure mathematical model and see what is happening. This is the model. And my boat's anchor point is somewhere here. This is the anchor point of the boat. Do you agree? The boat is being pulled with forces now. Now let's draw the forces. So we have a force on this side, right? What is this force? T2. Okay, this force is T2, and we have another force which is like this, and we say this force is T1. First, identify all forces acting on the boat. There is a water force also which is pushing the boat on this side. So there is a force from the water also. So let's say this is the drag force of water. These are the three forces acting. If the boat is not moving, that means all forces in x-axis and y-axis should balance each other. Now comes the story of what you call resolving vectors. So let's resolve vectors. अभी बहुत interesting हो जाएगा. Let's see. Now, if I resolve T1, oh, we didn't show one more force. Can you tell me one more force is missing here? Let's see. टेंशन है. सोचो ना, बोट को बांध के रखा है, बोट का टेंशन है. Buoyancy has been balanced. The weight of the boat is balanced by buoyancy. That's why I did not draw the weight. Other than the boat's weight is also there, na? Weight of the boat, but that is being balanced by the buoyant force. That's why the boat is. चाहो तो draw कर सकते हो, जरूरत नहीं है. Okay, so that is being balanced. Now let us resolve these forces. T1 can be resolved vertically. Okay, so let's resolve T1 vertically. T1 can be resolved vertically in this manner, and T1 can be resolved horizontally in this manner. This is T1. So let's write it. And we said that the angle here is alpha, right? So this one becomes T1 sin alpha. This one becomes T1 cos alpha. Once you have made these two, T1 is gone. Three forces cannot act. या तो खाली इसको सोचो, or you think these two. But we want the problem to be solved in XY axis. So now T1 is gone from your brain. Have you understood? Similarly, let's also break T2. So how do you break T2? T2 will have a force on this side, right? And T2 will also have a force on, say, this side, right? So what do I call it? I call it T2, and this angle was beta. So this is T2 sine beta, and this is T2 cos beta. T2 sine beta and T2 cos beta. Understood? I think we are done. We're done. These are the forces. Now from your mind, you just forget this force. This is no more existing now. And similarly, this is also no more existing. Because you have resolved it into its components. Okay, na? Either pull his ears like this or pull with one force. You prefer to pull with both sides. तो तीन से तो नहीं कर सकते ना, ठीक है ना? अब इसका मैथमेटिक्स करते हैं. If the boat is not moving, this force must balance this force. So one equation we can write. T1 cos alpha plus T2 cos alpha. Both the forces are pulling cos beta. Both the forces are pulling this side. They must be balanced by the drag force of water. And these values will be given to you. They will give one tension. ये दे देगा, ये दे देगा, ये दे देगा, ये निकल जाएगा. Or else one more relation, T1 sin alpha must be equal to T2 sin beta. T2 sin beta. So from here also you can take a ratio of T1 by T2 sin beta by sin alpha. So ऐसे होता है grade 11 के problem. These are classical mechanics. ठीक है? Any more doubt? हाँ, ये आपको बताता है कि कैसे हम फोर्सेस को तोड़ सकते हैं. But what you'll do in grade 9 is much more simpler than these. Or else, if you're more interested, we can do these classical problems. These are 16th century problems of physics. There's a rope, right? And there will be a nice little monkey. Monkey इस rope को पकड़े बैठा है और monkey लटक रहा है. Rope, ये drawing wrong हो गया. तो monkey is rope फट नहीं रहा है. What is the equilibrium diagram? Weight of the monkey is balanced by the tension of the rope. If the monkey exceeds the tension, धड़ाम से गिरेगा. ठीक है ना? So you should always give a monkey, select a monkey which is within the tension range of this rope. Same thing we use for cranes. So in engineering we used to do crane balance. Crane itself also has to balance. If a crane is lifting too much load, crane ही धस जाएगा नीचे. On rainy seasons when there is accidents happening on highway, truck पलट गया, first the crane driver will come. Truck work भूल जाओ. He will take half an hour to only do मुआयना and do ऐसे देखेगा. If he is not satisfied, he will never ever do the job. The crane has got something called outriggers. It will come out and it will position on the ground. And if the ground itself is, then the crane will never position. Do you know that? The crane will never position. Topic of work. Let's understand what is work. By less time, but still, let's see whatever we can cover. So, let's say, in order to understand work, we first have to have something called, you have to have a body. I don't know why my diagrams nowadays become all ulta. Okay, we have to have a body, and let's say this body is on a surface. This body is on a surface, and this body is acted upon by a force. Force, right? And पहले समझिए. Okay. First understand, then it will become very easy. Okay. Right. This is a force acting on a body. This is a body. As a result of this, you expect the body to move. A net force acting on a body, state of rest will change, and the body moves till here. And it actually covers a displacement of S. Now let's see what is the definition of work as per physics. Work is said to be done when the point of application of force, very important is the word called point of application of force. This is the point of application of force. When the point of application of force moves along the direction of force. These two words are very important. Okay, so we say work is said to be done when the point of application of force moves along the direction of force. Has to move along the direction of force. Very very important. Along the direction. किसी और डायरेक्शन में मूव करने से नहीं चलेगा. सर किसी और डायरेक्शन में मूव करता है क्या? हाँ करता है. तब क्या करेंगे? We will see. First these two things. Point of application. This point, look. Now when we study physics, we bring everything to point concept. So my point of application is this. You can also take the center of this body as the point of application. It's the same concept. ये यहाँ से यहाँ गया तो center has gone from here to here. So this is a displacement. Moves means this gives the birth of something which is known as displacement. This is displacement. So this is the definition. So in order for work to happen, what all you should have? You should have a body. You should have a force acting on the body, and the body should move along the direction of the force. Means the body should undergo some displacement. Now, what is the mathematical definition of work? Work is said to be the dot product of force and displacement. Please understand, dot product. आपको वेक्टर में डॉट एंड क्रॉस प्रोडक्ट पढ़ाया है? नहीं, लास्ट क्लास में मैंने पढ़ाया. Dot product will give you a scalar. Scalar is known as dot product. इसीलिए तो मैंने पढ़ाया. रीजन है, ऐसे नहीं पढ़ाया था. Dot product means first understand. We will take time to this will इतना easy है, 1 मिनट में थोड़ी खत्म करेंगे. So force is a vector, you agree. Displacement is a vector. Force and displacement being two vectors can be multiplied in two fashions. Scalar product or vector product. If you do a vector product, then the child is also a vector. But work is not a vector. Work is a scalar. So the product that happened was a scalar product. Scalar product is also known as dot product. Are you understanding? Scalar product is also known as dot product. अभी कुछ लिखो मत. Just absorb what I am saying. Is known as dot product. Work is said to be done when the point of application of force moves along the direction of force. समझ में आया? So we can, this is a vector, and I had taught you about translation of vector. Please keep eyes here. Mishka, छोड़ दो book. Please keep eyes here. This can be translated. So the force can be brought here also along the horizontal. Now tell me, in this particular thing, I told you that a force is a vector. I can break the force into two forces. One is vertical component and one is horizontal component. Keep that in mind. Huh? Let us go by mathematics and try to solve the value of work. Will only have a magnitude. What is the magnitude? What is the magnitude of work? Whatever is the magnitude of force, no direction, no plus, no minus, only plus, only value. Whatever is the magnitude of displacement multiplied by cos theta. Now what is theta? Theta is the angle between these two vectors. So let's see. My displacement is happening in this direction. Do you agree? And my force is also in this direction. Yes or no? In this particular problem, F is in this direction and displacement is in this direction. What is the angle theta between two? 0 degree. Therefore, in your book in grade 9, they will write work is equal to Fs. That Fs comes from here. Fs cos 0. Fs cos 0. We will attack it with two ways. Work is the dot product of two vectors. What is dot product of two vectors? Modulus of one vector, modulus of another vector into cos of the angle. In this case, force is in this direction. displacement is also in this direction. Yes or no? So the two vectors maintain an angle of how much? 0 degree. Cos 0 is 0 as per our table. Cos 0 is 1. 1. So this becomes Fs cos 0, which is equal to Fs into 1. So your book writes, in your book you will find this as the formula. This formula came from here actually. समझ में आ रहा है? And this is a typical condition when the force is along the direction of displacement. अब दूसरा चीज देखते हैं. दूसरा चीज. What is F cos theta? Now just separate this. Separate this. W equal to F cos theta into S. I can write like this also. Means into means don't confuse between dot and into. This is not cross product now. You're using only scalars. This is the magnet. When we use vectors, we put arrows. What is F cos theta? F cos theta is the horizontal component of the force. This force is already horizontal. So it can have the horizontal component is the force itself only. It cannot have any other vertical component. A force can be resolved into any vector can be resolved into two components which are 90 degree to each other. The original itself is at 0. How will you resolve it now? You can't resolve it. So इसको अगर हम resolve भी करेंगे, F cos theta is what? F cos theta is the force which is in this direction only. This is another proof why in 11 and all we never say work is Fs. Work is always Fs cos theta. This ensures that why Fs cos theta? Because when you say this, you are practically meaning force in the direction of displacement. What was our definition? Work is said to be done when point of application moves along direction of force. Brings us to now one more thought process. इस बहुत टाइम है पढ़ने के लिए हमें साल में. आप पहले enjoy करो इसको. Let's see a very common example which I gave in the last class. Okay, let's see that example. My example was that there is this toy car. There is a toy car, and the toy car is being pulled by a child. Which direction is pulling it? F. And the toy car is actually undergoing a displacement in this direction. ये बड़ा common है हमारे लिए. Toy car में toy car goes in this direction. Let's say the angle is theta now. Now we have to say, is work happening here? But as per our definition, point of application is not moving along the direction. So you will say, no sir, work is not happening here. Work is happening. But here we have to see this force has to be now broken down into two components. So let's see if we break down this force, then what are the components of this force? There is a vertical component which will be very small if you want to complete the rectangle. However, you will see the dominant component will always be the horizontal component, right? This is Fx and this is Fy. Now you are, and then this force is gone. Now you ask a question, is there a force along the direction of displacement? Yes. And what will you define work as? That force which is along the direction of displacement multiplied by the displacement and the dot product of both. Right? So if you see the dot product in this case, either you take the force and you just multiply it with the displacement which is in the direction, or else if you are using this force, then go by the dot product of two. Let's see both में आपका answer same आएगा. Let's solve the dot product. What is this? Fs cos theta. Can I not write it as F cos theta into S? And what is the value of Fx? F cos theta into S. So if this definition is more motherly definition, it does not consider the specific case of that always force will be in direction of displacement. Force can be in any way. Pull his hair this way, but his face is coming in this manner. समझ में आ रहा है? In that case, if I use this force, then I'll use the dot product of this force with the displacement. Or else I break this force into two components and utilize only this force. And this force is nothing but the cost component of this. अभी एक बहुत बढ़िया एग्जांपल देखोगे, मजा आ जाएगा. ये देखो, girls cannot travel light, they say, and say suppose you are traveling in train and you take a porter service. You're taking a porter service and the porter is taking all your suitcases and walking along the platform and then ultimately takes off the suitcases and asks you for money. You should not pay the porter, but the porter will be very angry. Then you have to explain physics to him. Let's see that. This is our porter, right? And our porter is carrying, say, Adya's suitcases. Agreed? And let's see the analysis of forces for this porter. Weight of all these are acting downwards of all the suitcases that she has loaded, F. And the porter will be walking horizontally. Scientifically, this is correct. What is the angle between both? 90 degree. And you tell the porter, भैया कोई पैसे ही नहीं दूंगा, आपने तो वर्क ही नहीं किया. क्या वैसा वर्क नहीं किया, मजाक कर रहे. फिजिक्स कहता है वर्क का डेफिनेशन होता है F डॉट S, है ना, दो वेक्टर. Fs का मतलब होता है Fs cos 90. cos 90 तो जीरो है, आपने कोई काम ही नहीं किया है, आपको पैसे नहीं देना चाहिए. This is correct actually. Work done by a satellite in moving around the earth is zero because the force is always tangential to the displacement. Just see, this is earth and the satellite is moving in a circle. The satellite is being pulled towards the earth. This is the gravitational force and the displacement is always at 90 degree. Work done is zero. Another thing, let's say a ball is being pushed this side. There's a frictional force which is here. This is a frictional force. And now the ball is moving in this direction. What is the work done by the frictional force? Somebody tells you. What is the work done by the frictional force, not by the kick force? This is say the kick force or the push force, whatever. There will be a friction with the ground, na? Which will be pulling the ball, retarding the ball a little bit this side. That's why the ball slows down. Work done by the friction force. You will go by the formula. Work is equal to friction force dot S. So it will be friction force into S into cos of 180 degree. And 180 degrees value is -1. So this will be negative Fs. And I just want you today to go and see your NCERT book. You know what they will say? NCERT will say, if force is in this direction, displacement is in this direction, work is equal to Fs. If force is in this direction, displacement is in this direction, work is equal to 0. If force is in this, displacement is in this direction, force is in this direction, and they are opposite, work is equal to negative Fs. But why it came? They don't tell you. Now you know this is 0 because cos 90 is 0. This is negative because cos 180 is -1. And this is Fs because cos 0. What you know more than your friends in your school is that here there is a hidden cos 0, here there is a hidden cos 180, and here there is a hidden cos 90. That's the reason of teaching you trigonometry in one class before starting this. Now you will be able to correlate any problems, and a lot of problems will be given here. A boy pulls it with a 20 Newton force, undergoes a displacement of 3 meters, maintaining an angle of 60 degree. Find the work done. So we can do it. W is equal to 20 into 3 into cos 60, which is equal to half. Sin 30 is half, so cos 60 is half. So कितना हो गया ये? 10 into 3, 30. Now what is the unit of work? Joules. We'll revisit this. Today we had only 15 minutes, so we'll not cover much. Yeah, I'll go to the previous one. What doubt you have, you tell me. Okay. Acha, one more thing that we will cover in next class. इसको मैं फिर से पढ़ाऊंगा. Works unit is always joule. So define 1 joule. 1 joule of work is said to be done when a force of 1 Newton displaces a body by 1 meter in the direction of force. Don't miss the word in the direction. Now, then you should ask, sir, where was the in the direction here? When you take cos 180, you have actually taken, this is FF cos 180, which is negative. Sir, where was in the direction? This is F cos 90, which is actually 0, which is actually negative FF. If FF was this side, negative FF is this side. Now you see what is your work's definition. Force, displacement in the direction. Force is negative FF. Displacement is S, so it is negative FFS, which comes from this formula. ये थोड़ा सा वीडियो भी देख लीजिए, नोट्स मत बनाए. Next class when you come, we will be studying this in proper manner, and then we will say what is definition of work. We will write them. How do you get a joule? A joule, then what is the difference between work and energy? So today we just understood work. Work होने के लिए we need a body. We need the body to be acted upon by a force, and we need to find, is the displacement along the direction of force? Sir, exactly, it's clear. If it is not clear, resolve the force. There must be some hidden. A paratrooper is gliding in this manner. Force here, but the paratrooper is going in this direction. Is there a work? There is a work. You have to resolve the forces. और 1 minute के लिए अगर आप देखोगे, if you have 1 minute of your life, then we can actually see that example also. Say this is our paratrooper. See, paratrooper is actually pulling. This is the parachute. Okay, this is the parachute, and paratrooper is actually pulling. So now if you see the tension from here, there's a tension T1 on this side and a tension T2 on this side. Clear or not? Now how is the paratrooper coming down? So let's break the paratrooper into a XY axis. So if you see, whatever angle will be here, considering the paratrooper exactly horizontal, if this is theta, this is theta. So this one becomes T1 cos theta, this one becomes T2 cos theta. Both will be in opposite direction, balance each other and cancel. Then here we will have T1 sin theta, and also we will have T2 sin theta. And here we will have, no, those two will not cancel, those two are acting. And here we will have W equal to mg. Mass, force is mass into acceleration. G, that's why you have not studied gravitation. देखो यही तो problem है ना. This is his weight. Motion के लिए भी जो force का definition होता है ना, force is mass. So if the paratrooper has to come down, what should be the condition? Let's see your physics knowledge. If the paratrooper, now ये सब चला गया, T1, T2 are gone. Yes, the moment when his weight will be more than this, that is the moment when he will start moving down. But you have not accounted for one force out here. There is lot of air in the atmosphere. The moment he opens his parachute, he will first go up because there is a huge amount of drag force. Understood? The drag force will pull the paratrooper up first, and slowly he will descend. Then there will be a time when his upward force will be exactly equal to his downward force. Net force, 0. No acceleration. That time the velocity is known as terminal velocity. He will come down with no acceleration. And as he comes down little bit more, these drag forces will reduce. And you will see, oh, to aa gaya hamara mishka, and then you will see the speed is increasing of the paratrooper gliding. First, when the paratrooper will open the parachute, the paratrooper will go up. His weight will be very less. That's why they do all this photography, selfie and all. They are least bothered at that time. Utna dar nahi lagega aapko bhi. Once you open, dhak, you will be pulled up. Then there will come a portion when your upward force, downward force will be equal. No acceleration. You will be going under uniform motion. That velocity is called terminal velocity. Commandos के लिए बहुत important है. After that, the air will come down, because in commando operation you have to come down very quickly at night. The air will come down. If the air comes down, now the weight increases. So now what will happen? There will be a net force downwards. Whenever there is net force, there is acceleration. Very quickly the paratrooper will come down to the ground. Similar things happens when you make a rich shake and you add chia seeds in it. Chia seeds or a piece of grape dropped in a mango shake will go down to some extent. After that, it will face buoyant force from the mango shake, and the chia seed or the grape will exactly remain suspended. That's called the terminal velocity of the grape, where the grapes will be exactly at the middle. देखिए ना, चिया सीड वगैरह पहले पहले टिक 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 जाएगा, फिर पूरा नहीं जाएगा, एक जगह जाके रुक जाएगा, थोड़े टाइम के बाद वो ऊपर भी आ जाए, तो उसको buoyant force मिलना शुरू हो गया है, क्योंकि वो जैसे ही फूल जाता है वो हल्का हो जाएगा, वो ऊपर आ जाए. Yes. Okay. Same thing happens with dead bodies. Why do dead bodies float after some time? है ना? Dead bodies के अंदर गैस फॉर्मेशन हो जाता है, और गैस फॉर्म होते ही डेंसिटी इज इक्वल टू मास पर यूनिट वॉल्यूम, वॉल्यूम बढ़ जाता है, so density comes down and the body will float up. हाँ, फोरेंसिक में तो यही चीज देखते हैं ना. How do you understand otherwise कि किसी को मार के फेंक दिया